Here's a question from JEE 2012, Maths Paper 1, and it says that let f from reals to reals be defined as the following function. The total number of points at which f attains either a local maximum or a local minimum is. And this is an integer type question, so the answer has to be a single digit integer. So we have a few cases to deal with here, as we always do with questions that deal in absolute value. We first write f in a more simplified form, so this will be mod of x plus the product of x minus 1 and x plus 1. And now we have a few intervals to deal this in. The first is when x is less than negative 1. And in this interval, we know that this entire product is positive and this is negative. So mod of x is going to be equal to negative x, and this entire thing, this entire product, is just going to be equal to the same thing. And so this, for this interval, f is equal to x squared minus x minus 1. Then the next interval is for x between negative 1 and 0. And in this interval, we know that this product is negative. So the mod of x squared minus 1 is going to be equal to 1 minus x squared. Plus, this thing is going to be negative as well. So that means we are again going to have a negative x right here. And this will give us 1 minus x squared. The third interval, as we just keep going, is between 0 and 1. And in this interval, mod of x is just going to be equal to x, since x is now positive anyways. And x squared minus 1, well, that's still going to be negative. So its absolute value will be equal to 1 minus x squared. So this will be x plus 1 minus x squared. The fourth interval is going to be wherein all the product as well as x are going to be positive, and thus we can just immediately write them as x plus 1, sorry, it should be x plus x squared minus 1. And now we want to find the number of local maxima or local minimum. So the best way to do that, since all of these are differentiable functions, is to just write their derivatives right away. So let me just write f dash of x. And so this will give me 2x minus 1. This will give me negative 1 minus 2x. This is going to give me 1 minus 2x. And this one is going to give me 2x plus 1. And once that is done, once the derivative has been figured out, we can now write this to be equal to 0, and this gives us all points at which the derivative is equal to 0 and may have a local maxima or a local minima. So this equation, upon solving, gives you x equals half. But notice x equals half does not lie in this interval, hence this will not be a possible contender. This interval is going to give you x equals negative half, and it does lie in this interval, and this will be counted as one of the points. This interval gives solving this equation gives you x equals half, and it again lies in the interval we're talking about. This one gives us x equals negative half, and it does not lie in here. So we have got two local maxima here, but notice we only get local maxima for the non-boundary cases. What about the places where the derivative straight away does not exist? Because that also can be a critical point. So at x equals negative 1, if you figure out at x equals negative 1, the left-hand derivative, that is going to be equal to negative 3. Just plug in negative 1 here. And the right-hand derivative is going to be equal to 1. And since this place the derivative ceases to exist, we can consider it as a point of local maxima or minima. Similarly, at x equals 0, the left-hand derivative is equal to -1, and right-hand derivative is equal to 1. Hence, again, the limit ceases to exist, and this can be a possible place for local maxima or local minima. At x equals 1, the left-hand derivative is equal to -1, and the right-hand derivative is equal to 1, and again, the derivative ceases to exist, and this again gives you a critical point. And that's it. We have 5 points for second. This is the third, this is the fourth, this is the fifth. And we can also go on and plot the function, but we can just save ourselves from that work and straight away say that 5 is the number of points where there is a local maxima or a local minima without specifying which one is which.